Hello learners, welcome to Education Online program. In our previous lesson, we looked at the difference why we're not considering the horizontal and the vertical motion together. We saw very many reasons, if you're using the equations of motion. So since we know so many equations of motion now, and we say that at the vertical height, our initial velocity there is our u is equals to 0. So this one affects all the equations where we came about with our v being only equals to gt for the first equation of motion, that is at maximum height. Then we saw that our s, the distance, was equals to what? It will give us a half g t squared. Then we looked at the velocity here will give us a 2gs, but then if you get the root, we shall have v is equals to root of 2gs. This applies when the body is at maximum height, because there our initial velocity becomes 0. So if we have this, we also talked about the time of flight being 2t. So if we know all this, I guess now we can move to calculations. We try to see how we can apply these formulas. So our first question is talking about a ball that is hit horizontally off a cliff with a velocity of 30 meters per second. If it takes 5 seconds to reach the ground, we have to calculate the height of the cliff, the horizontal distance from the foot of the cliff to the point where the ball lands. And we're also talking about the velocity with which the ball hits the ground. Let's have it on the board so that we can refer so much easily to it. This is our example. Example 1. We're talking of a ball is hit horizontally off a cliff with a velocity of 30 meters per second. If it takes 5 seconds to reach the ground, we're going to calculate the height of the cliff we have to get the horizontal distance from the foot of the cliff to the point where the ball lands. So we shall also have the velocity. We need to get the velocity with which the ball hits the ground. Now there we have our question. So what we have to do is we read the question, we understand our question. When we've understood the question, we can easily find out what has been given to the in the question and what exactly we want to find in the question, and then the appropriate formula we can easily adopt and apply to our question. So if we look at the question, it's saying a ball is hit horizontally. Let's take a note of this. Horizontal of a cliff with a velocity of, which velocity have they given us? Is it the initial velocity? Is it the velocity when the body is moving horizontally, or it is the velocity for the body when it is moving in the vertical direction? You take note of that. If it takes 5 seconds to reach the ground, this is the timing. What timing for the ball to reach the ground? Then here they were telling us to calculate the height of the cliff. How shall we calculate the height of the cliff? So if you look at our question, they are talking about the ball is hit horizontally. So there is this element of the uniform velocity. Now meaning that the velocity they have given us here, which is 30 meters per second, is actually the initial velocity with which the body was started, but in the horizontal motion. So that is our ux, which is 30 meters per second. So if our ux is 30 meters per second, what was the initial velocity of this body when it was to start moving in the vertical motion? Meaning that our uy, which we are giving it the initial velocity when the body is moving in the vertical direction, will be 0 meters per second. So what else have they given us? If it takes 5 seconds to reach the ground, that is the time taken for the body to move from just that height, and then it hits the ground. So our time here is given to us as 5 seconds. Now what is the question requiring us to find? The height of the cliff. So how do we get the height of the cliff? If we use the horizontal distance, will you find the height of the cliff? No. Because this horizontal distance gives us the point from the foot of the cliff to where this ball will actually land. That is just the horizontal distance. Because if you consider that, that means that you don't know now how high the cliff is. So to know how high the cliff is, we are going to use the vertical motion. So let's take it as our Roman A. But then here, which equation are we going to take? We have these two equations in this point here. We are taking only the two that has got the element of distance. So we shall have the second equation of motion, which is S is equals to ut plus a half gt squared. Then we have this, which is v squared is equals to u squared plus 2g gs. Here, which equation shall we use? You also have to be keen about the selection, because at this point, if you take this third equation of motion, where are you going to find your final velocity? Do you have the final velocity already? No. But what we have there is the initial velocity, meaning that we cannot use this formula here, but we can use this equation because we know the value of acceleration due to gravity. We know the time. We have the initial velocity. So here, our value of acceleration due to gravity, we are actually going to consider 10. Our g will be equals to 10 meters per second squared. So now if we are considering the vertical motion. So if we're considering that, we're going to use this, which is going to give us, at this time we are taking Sy is equals to, we have our uyt plus a half gt squared. What is our Sy? It is the height of the cliff we want to find. It's the unknown in our equation. So we shall leave it as our Sy is equals to, what is the initial velocity for the body to move in the vertical direction? We already had it there. So it is 0 meters per second. We shall substitute it right here. So we're having, what is the time taken then for the body to hit the ground? We are taking that time for the body to hit the ground because it was coming from the, it is taking the vertical motion. It is that timing from just that up of the top of the cliff up to its foot. That's why we're considering it as the 5 seconds there. So we shall write it right here. We shall have it plus a half times the acceleration, which is 10, times the time, which we have 5. But don't forget to square it, because here our t is squared. So we shall have our Sy. Sy will be equals to 0 times 5 will give us 0 plus a half times 10. So if you have a half times 10, what shall we get? A half times 10 will give us 5 times 5 squared. 5 squared is more like 5 times 5, which will be 25. So we shall have our Sy is equals to 5 times 25. What shall we have? We have our 25. We are multiplying it by 5. So we shall have it 5 times 5, which will give us 25. You write 5 carry 2. You have 5 times 2, which is 10. Then you add what you carried to give us 12. So here we shall write our 12, meaning that our 5 times 5 is 125. So we shall have our Sy is equals to 125 meters. So if we have this, it means that the height of the cliff is 125 meters. So the ball was thrown from this point here, from this height here, the height of 125. So we can say that the height of our cliff, is 125 meters. So what is our next? It's saying that the horizontal distance from the foot of the cliff. So how do you get this horizontal distance from the foot of the cliff? Because for you to find this, assuming that this is our cliff, this is our cliff here, and our cliff, when we calculated, we found that this height from the top up to the bottom of the cliff is 125 meters. So the ball was hit from here, went horizontally, and then came to the ground. So here, this is our Sx. So now here, they want us to find the horizontal distance. So from the foot of the cliff, it's just like what I've drawn. It is from this point here up to the point where the ball hit the ground. So this one is what is meant by the horizontal distance. How do we get that horizontal distance? So we can say our horizontal distance from the foot of the cliff, we are considering the horizontal motion of our ball. So we're going to have it as our x is equals to u x t plus a half g t squared. But remember, when it is vertical like this, horizontal, what happens is that the acceleration due to gravity here is equals to what? Is equals to 0. So at this point here, there is no force of gravity acting on our ball. So we shall have our sx, which will give us the initial velocity with which the body was thrown from the horizontal position is 30 meters per second. So we shall have here as 30. So we are multiplying it by the time, that is 5, plus a half. Our acceleration this time is 0 times the time, which is again 5, but also squared. So if we have it like that, we shall have our sx is equals to, if you get your 5 times 30, what will you have? So you have your 30 here, you want to multiply it by 5. You will multiply 5 times 0, which will give you 0, 5 times 3, which will give you 15, meaning that 30 times 5 is 150, plus this is a half times 0 times 5 will give us 0. So our sx is equals to 150 meters. That means that the ball landed at a point 150 meters away from the foot of the cliff. If you do not want to use the whole of this, and you already know that acceleration due to gravity is 0, you just have it as your s. So you can also have it as your s is equals to, since we calculated already and we know that this one here is 0, from the equations we had, we shall see that our s is equals to ut. So if it is ut, we shall see that our sx is equals to our u, which is already 30, times the 5, which our sx will give us 150 meters. Either way is also okay. Here we just eliminated the whole of this because we know it is 0, because of the value of the acceleration due to gravity. Now our next question is telling us to find the what? It wants us to find the velocity with which the ball hits the ground. How would you find the velocity with which this body hits the ground? So we found this, we are seeing the values there. Now let's find our last. Roman 3. The velocity with which the body hits the ground. Now if you want to find that velocity, whatever do you actually consider? Do you consider the vertical, or you consider the horizontal motion? So we see that we had that our ux is equals to 30 meters per second, and we know that when it is in the horizontal, we know that our g is 0, but then our uy, we also have it as 0 here. So what else did we get? We got our sy, which is giving us 125 meters. So what do we have again? We have our Sx, which was 150. Now they want us to get the velocity with which the body hits the ground. You can have, we have this equation. We have V is equals to, we have V is equals to U plus GT. We also have this equation, S is equals to UT plus a half GT squared. We also have V squared is equals to U squared plus 2GS. Which one are we going to use? If you look at the first and the second, we calculated their distances already. We found we have the S. Now look at this. There we did not have the S, but we know we have the initial velocity. We had the initial velocity for both the motions. We had it when the body is moving in the horizontal, and then we also had it when the body is moving in the vertical direction. So meaning that we can now take our first here. So if you want to get this velocity with which it hits the ground, we can consider the vertical motion again. Why are we considering the vertical motion? We are considering the vertical motion because it was moving in a vertical direction. Because if you look at this, if you take a look at this moving like this, so you see that it is taking vertical, not the horizontal, not moving this way. So let's take a look at that. And then on top of it, if you're using the horizontal distance, we are saying the horizontal distance, the final velocity is equals to the initial velocity. We shall have it as our U. We are now taking this because this one is not applicable and that. So we shall take V is equals to U plus GT. It is the V we want to find. So do we know our U in this? Do we know our U? Yes. We already know our U because we see that at the vertical, the initial velocity there was what? Was 0. So we shall have our U. Our V here is equals to the U, which is 0, plus the acceleration due to gravity. We also have it as 10. So what was the time taken for the body to actually hit the ground? It took the body 5 seconds. So we shall have our V is equals to 50. We are taking 10 times 5. So if we have it like that, this is in meters per second. Now I hope we've got how we calculate, how we use the equations that we had in our previous lesson. Because now here, if you also don't want to write the whole of this, in our previous lesson we saw that at vertical, at maximum height, when you reach the maximum height, our U is automatically 0. So you can just write our V is equals to GT, and then indicate that it is at the maximum height. So you can just do that and substitute it direct. 10 times 5, you also get the same answer, which is 50 meters per second. So we should be very keen which motion we are taking, which direction is the ball taking, because the moment we confuse the two, we shall end up with wrong answers. And then not only wrong answers, but even the formulas, the equations we shall choose will be not appropriate for the question. We have another question here talking about a bomb which is released from a jet fighter plane moving with a velocity of 400. This one was from the top of the cliff. Now let's check this other example here. bomb is released from a jet fighter moving with velocity of 400 meters per second to hit a rebel a rebel camp. If the bomb took 10 seconds to hit the target, calculate. We have our A. We want to find the altitude. The altitude at which the bomb was released. We also have the horizontal distance. From the horizontal distance from the vertical point of the plane to the target. So we also need to find the velocity. The velocity with which the bomb hits the target. So our question is saying that a bomb is released from a target from a jet fighter moving with velocity of 400 meters per second to hit a rebel camp. If the bomb took 10 seconds to hit the target, we are calculating the altitude. So before us coming here to calculate the altitude, let's first summarize our question. Do we have what kind of velocity is that? Is it for the motion in the horizontal direction, or it is for the vertical motion? So let's take a look at that. It is a bomb is released from a jet fighter. Imagine this is your jet fighter. Okay, let's have a small diagram like this. We assume this is our jet fighter. So this jet fighter is releasing the bomb, and it is moving with a speed of what? 400 meters to hit the rebel camp. Which velocity is this that they have given there? Which velocity is this that the question is telling us? So we should know which velocity is this. Is it the initial, or it is the final velocity? Is it for the horizontal, or it is for the vertical? We shall find all that in our next lesson. Since we've seen the first, I hope now we can use the equations and the idea from the first example to calculate this in our next lesson.